This video will be about factoring when a is not 1. Now the key to these to make your life a lot easier is to keep in mind this hint to always check your trinomials for a GCF, because several problems, as we did in video 1, may look like there's a coefficient in front of the x squared, but in fact there's just a GCF that needs to be factored out, and then we can handle the trinomial just like if a was 1. However, you'll see the difference on this worksheet is that, for instance, in the first one, there is no GCF that I can factor out, so there's no way that I can turn the 5 that's in front of the x squared into a 1. So we're just going to have to deal with it. So the best way to handle that situation is with this trick. So we're going to go ahead and set up our t-chart like we did prior. And the difference is that rather than looking for what multiplies to a and adds to b, is instead I'm going to take a times c and multiply to that instead. So I'll take 5 times negative 32, which this will give me negative 160. So rather than looking for factors of negative 32, I'm going to look for factors of negative 160. Now the other side remains the same, that I'm looking for what adds to b. So b in this case is a negative 6. Okay, so then from here we go through the same process we did when a was 1, only using negative 160. So start listing your factors of negative 160, and there are a lot of them, so you may have to go through quite a few trials before you find the right combination. And I'm immediately thinking about 10 and 16 being a good combination. Now remember that one of these has to be positive and one of these has to be negative to be able to multiply to get a negative 160. So now how you know which one to choose is that it has to add to give you a negative 6. Negative 10 plus 16 would give me positive 6. Positive 10 plus a negative 16 would give me negative 6. So that indicates to me that the second combination is the choice I'm looking for. Okay, so from here we'll go ahead and set up our pair of binomials. And I'm going to start off with x and x. And now I need to add in my positive 10 minus 16. And here's where the other part of the trick comes in, is that since a is no longer 1, I have to bring this back into the problem by dividing the second terms by a. Now from here, what we do is, if you can reduce this fraction, you want to make sure it's in lowest terms and simplify it as much as possible. So 10 divided by 5, that divides evenly into 2, so that I can change this factor to x plus 2. However, you'll notice on the second one, 16 over 5 does not divide evenly, nor can we reduce it. So this is where I'm just going to take the denominator and slide it right here in front of the x to give me my factor. So it looks like this. 5x minus 16 is your second factor. And that's this problem completely factored. Now you should be able to FOIL this back together and see that you get the same problem we started with. Let's try the next problem. So similarly, I'm noticing that there's no GCF that I can divide out of all three of these terms, so there's no way to get rid of the 2 in front of the x squared. So I'm going to do the same trick I just did on the first problem. So take a times c. A is a positive 2, and c is a positive 15. So this time I'm looking for factors of 30, so it multiplies to give me 30, and adds to my b term, which is negative 11. So again, start listing all your factors and options of numbers that will multiply to give you 30. And in this case, keep in mind that since it's a positive 30, we could have either both factors be positive or both factors be negative. So I'm not going to list all of these, but as you keep listing, you will come across the 2 that will sum to give you a negative 11. So then you can start summing these. And I see that the ones I need are going to be a negative 5 and a negative 6. Those are going to add to give me a negative 11. So when I come over here to set up my binomials, I'm going to have x minus 5 and x minus 6. And then don't forget to take into account that a is 2. So I have to divide each of these terms by 2. And then for this first one, the 5 over 2, that does not simplify. So this is where I'm going to take that little trick and just bring the 2, slide it right here up in front of the x. So this gives me 2x minus 5 as my first factor. And then for the second factor, 6 over 2, that does divide evenly to give me x minus 3. And there's this problem completely factored. Okay, this next one throws one more trick in there that I want to point out to you. So it starts off the same way that I'm looking for what multiplies a times c, so 4 times 3 is going to give me what the factors I'm going to use. So I'm looking for factors of 12, and then I need to add to a positive 8, my b term. Now we can continue listing our factors of 12. So I'm looking for what multiplies to give me 12 and will add to give me a positive 8. And keep in mind that both of these could be negative, but since we need to add to a positive 8, that's not necessary. So you find the right combination there. Positive 2 and positive 6 will give me a positive 8. So then I come back over here, set up my binomials, and I'll have x plus 2 and x plus 6. And then I need to keep in mind that I have to divide out a, which is 4, of both of these terms. And here's where the problem gets a little bit different than where we were working previously. So in this case, neither of these fractions can be divided evenly, but they can be simplified. It's very important that you make sure your fractions are simplified as much as possible before you start bringing the denominators up in front of the x. And I'll show you what happens if you forget to do that here in a second. So we will go ahead and simplify. 2 over 4 is simplified into 1/2, and 6 over 4 simplifies into 3/2. So now that my fractions are in lowest terms, now I can go ahead and take the denominators to pull up in front of the x to get my two factors. So this is going to give me 2x plus 1 for the first factor and 2x plus 3 for the second factor. And there's this problem factored completely. Now let me come over here to the side and see what happens if you forget to reduce your fractions. Okay, so let's say I got this far and didn't think about reducing my fractions, but went ahead and pulled the 4's up in front of the x's. You'll see that my answer is different than the correct answer we got originally. And in fact, if you were to try to FOIL this back together to see if you were correct, you'd see 4x times 4x gives me 16x squared, which is way too large for my original problem, because my original problem was only a 4x squared. So if you don't reduce your fractions, you'll end up with extra constants in your trinomial that were not there originally, which will make your answer incorrect. Okay, let's try the last one. So again, I glance through and see that there's no GCFs that I can take out of these. So I'll go ahead and jump in with multiplying a times c. So a is 8 and c is 3. So multiplying these together means I'm looking for factors of a positive 24. And b is negative 10. So then I need what's going to add to a negative 10. So start listing factors of 24, looking for a combination that will add to give you 10. And when I get to 4 and 6, I see that's going to add to give me 10, but since I need a negative 10, I'm going to need both of these to be negative. So there's my correct combination. Okay, so I come in here with x minus 4 and x minus 6. And then, since a is not 1, we still have to divide 8 out of both of these terms. And again, I'm left with a set of fractions that does not divide evenly, but is also not in lowest terms. So it's important that we make sure that this is simplified as much as possible. So 4 over 8 reduces to 1/2. And 6 over 8 will reduce to 3/4. Okay, so now our fractions are in lowest terms, so we can pull the denominators up in front of the x to get 2x minus 1 and 4x minus 3. And there's my answer completely factored.